Welcome. Let's take a look at an example where we have a polynomial of f of x, and we write it as a product of linear factors. If the objective is to write the polynomial as linear factors, then what we need are the solutions of the polynomial of f of x. Well, how many solutions does this function have? Well, we can see that the highest degree is 4. Then by the fundamental theorem of algebra, we should expect to have 4 solutions. And knowing that we have 4 different solutions, now we can start writing down how our linear factor is going to look like. It's going to have a coefficient of a, and it's going to have 4 different vectors. 1, 2, 3, and 4. And the spaces that we are leaving here, this is where we're going to be placing the different solutions in this polynomial. So now that's our objective. What are the 4 different solutions that this polynomial of f of x have? Well, let me clean this up and let's find those solutions. Well, one way to start finding those solutions is to graph the polynomial. So let's show the graph here on the right-hand side. When we graph it, notice that we can identify 2 different solutions at the value of -1 and also at the value of +2. So we can start placing those solutions here where we are writing our linear factor. The first solution is -1, so let's write it here. And the second solution is +2. So let's write it here. Now, how are we going to find these other 2 solutions that we are missing? We cannot identify them just by graphing. Well, one way to do that is to understand what we have done. Here we are saying that this polynomial, it has x plus 1 as a factor and also x minus 2 as a factor. So let's see what happens to this polynomial when we factor out x plus 1 and x minus 2. But let's do it one at a time. Let's factor out x plus 1. And I'm saying it x plus 1 because here we have minus a minus, which is a plus. So let me actually change that to a plus. Well, we can perform synthetic division to see what happens after we factor out x plus 1. Our polynomial, it's already in standard form. Notice that degrees are decreasing from 4 to 3 to 2 to 1. So let's get those coefficients. The value of 1, followed by -1, followed by 2, followed by -4, and then followed by -8. Now let's place our upside down box. And outside, let's put the opposite over factor. If we factor out x plus 1, then let's write a -1 outside. Now let's perform synthetic division. Let's bring down the 1. Let's multiply the outside, which is -1. And let's combine our result, which is going to give us -2. Let's repeat the process. -2 times -1, that is +2. Let's combine them. That's going to give us 4. Let's repeat the process. Multiply the outsides. 4 times -1, it is -4. And when we combine them, that's -8. Let's repeat the process. -8 times -1, but that's +8. And when we combine them, that's equivalent to 0, which is good. We were expecting this. This is our remainder. We were expecting our remainder to be equal to 0 because we already knew that x plus 1 was a factor. So now let's write down our result. Knowing that we started with a polynomial of x to the 4th, then the results of our synthetic division, 1 is going to be the coefficient of x to the 3rd. It's always 1 less than what we started. -2 is going to be the coefficient of x to the 2nd, or it's going to be the coefficient of x. -8 is going to be our constant. So now we can say that f of x, it can be written as what we have factored out, which is x plus 1, and then what we obtain from the result of our synthetic division. 1x to the 3rd, -2 x squared, plus 4x minus 8. So now that we know what's the result, when we factor out x plus 1, Let's repeat the same process and see what happens when we factor out x minus 2. So let me give myself some space by erasing some of the work. So now let's see what happens when we factor out the expression of x minus 2. Let's perform synthetic division one more time. But we are not going to perform synthetic division on the polynomial that we started. We are going to perform synthetic division on the result that was left once we factor out x plus 1. So let's set up our synthetic division. We got a coefficient of 3, followed by 2, followed by 1, followed by 0. So very good. Let's get those coefficients of 1, -2, 4, and -8. And now let's do our upside down box. And then on the outside, if we want to factor out x minus 2, let's put a 2 outside for synthetic division. Now let's perform synthetic division. Let's start by bringing down the first value, which is 1. The outsides, let's multiply them. That's equivalent to 2. Let's write that down here. Let's combine. That is 0. Let's repeat the process. 0 times 2, that is 0. So let's write it underneath the 4. Combine them, that is 4. Multiplied, 4 times 2, that is 8. Let's write it underneath -8. Add them up. Now we got 0. But we were expecting this because we know that x minus 2 was a factor. After a division, we should expect to have a remainder of 0. So let's write down our result. Our polynomial of f of x. We can write it out as a x plus 1. But now this expression that was left, it can be written out as x minus 2 and the result that we get for our synthetic division. We started with an exponent of 3. So we know that 1 is going to be the exponent of x to the second, 0 is going to be the exponent of x, and 4 is going to be the constant. So now instead of writing this whole expression, let's write it out as x minus 2 times 1 x to the second plus 0x, which I'm not going to write, plus 4. Let me erase some of the work because we need the space. And now we're one step closer because this expression of x squared plus 4, if we solve for that, it's going to give us the 2 linear factors that we are missing. So let's solve for x squared plus 4. Let's set it equal to 0. Move the 4 to the right by subtracting. And let's solve for x by taking the square root. So we have that x is equivalent to plus or minus the square root of -4. But we can write this down as positive 2i and negative 2i. And we are done because now we have the 2 other solutions that we were missing. So let's put that down in our linear factor form. Let's erase our third factor and let's put the value of 2i. And let's put down the fourth solution in our fourth factor as negative 2i. Let's just clean this up, and instead of calling it minus a minus, let's just call it a plus. The product linear form of the polynomial that we were given, it can be written as some coefficient, let's call it a, times x plus 1 times x minus 2 times x minus 2i times x plus 2i, which is what we were looking for. So just keep this in mind. If you want the linear factor form, think about how you can get the solutions that are needed. Because once you have those solutions, then it's just a matter of placing them in the location that are needed. We have 4 different linear factors because we had a 4-degree polynomial. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.